Hey everyone. In the last two videos, we discussed two of the pillars of machine learning, which is linear algebra and calculus. In this video, we're going to be discussing the final pillar, which is statistics. Specifically, we're going to be going over the mean and median, the standard deviation, a distribution, and the Gaussian distribution. The mean or the average is found by summing together a group of values and then dividing by the number of values. So let's say we have a vector of 9 values, and these could be heights in centimeters. So that's our vector right there. And to calculate the average height, we sum all of the heights together, and then we divide by the number of heights, which is 9 in this case. And then we get the average of 166. Now, in maths notation, we can calculate the mean as using this formula. So this symbol right here is called mu, mu. It's the symbol that's often used to represent the average or the mean. So what this formula means is this first part here is the sum of all the elements. So let's say x is our vector of numbers, and we go through all the elements from I equals 1 to I equals n, and we just sum all those elements together. Then we divide by the number of elements, which is the same as multiplying by 1 over the number of elements. And that's what we're doing here. And that's the formula for the mean. Now, the median doesn't have a similar formula. It's more like a strategy that you need to use to find the median. So the median is the middle value. And to calculate the median, the data must be sorted. So here's the same vector of 9 heights. And the first step is to sort the heights in ascending order or descending order. So you can see here that we sorted it in ascending order. So we have the lowest element here and the highest element here. To find the median, we just find the middle value, so the actual middle value. So since there are 9 elements, the median would be the 5th element, since there are 4 to the left and 4 to the right. If there are an even number of elements, then we just take the 2 middle elements and we average them together. So in this case, 166 is the middle value, and thus it is the median. Now, in this example, the mean and median happen to be the same, but this is usually not the case. Now, let's say that I am able to calculate the mean, and I have a group of people who have certain heights, and I was able to calculate the average height. What if I want to know what's the average distance or difference between the average height and everyone else's height? So in other words, how spread out is the distribution of heights? So standard deviation is a measure of how spread out or dispersed a set of values is. In simple terms, it tells you how much individual members in a group differ from the average of that group. And here's the steps to calculate the standard deviation. It also has a formula, but we'll go over that after we go through the algorithmic steps. The first step is to subtract the mean from each member or each element in the vector. So we have our vector of heights here, and what we're doing is we calculate the mean, which is 166 as we calculated before, and we subtract that from each value in the vector. So 187 minus 166 is 21. And then we square these numbers. So we take 21 and we square it, and that gives us 441. Finally, and we do that for each element in the vector. Finally, we sum these differences. So summing all these values up, we get 4936. The next step is to divide by the number of members. So we take 4936 and divide by 9. And then the final step is to take the square root. So this is the square root is kind of undoing all those squares we did earlier. And we get a value of 23. And this is the standard deviation of this vector of numbers. So what does the standard deviation tell us? Well, it tells us that on average, people are 23 centimeters shorter or taller than the average height. So that's kind of the range, that's the approximate range you can get of these heights. Now, the standard deviation also has an equivalent mathematical formula. And if you go over the previous steps and you try to understand how this formula works, you'll see that this formula is just a mathematical representation of the above steps. So the first step was to subtract the mean. So that's what we're doing here, x of I minus mu. The next step is to square the differences. So we square those differences. And the next step is to sum all of the differences. So that's this sum operation here. Then divide by the number of elements, and then finally square root. And standard deviation is commonly denoted with the Greek letter sigma. Now, it's not too important that you remember this formula, but it's really important that you should understand the information that standard deviation actually is telling you. And that is that it measures the spread or dispersion of a group of values. Okay, so we've been using this term group of values a lot, and well, yes, it is a group of values, but in statistics, we like to call it a distribution. So up until now, we've been viewing a distribution as a vector of numbers, but there's actually a really nice way of visualizing these numbers, and that's called a histogram. So here we have a histogram of heights, and this is the height distribution. You can see we have height on the x-axis and the count on the y-axis. So the graph on the left is called a histogram. The blue vertical bars are called bins, and each blue vertical bar represents the number of people in a particular height range. So you can see this tallest bar here. It doesn't represent a single height, or it doesn't necessarily represent a single height. It could represent maybe 170 centimeters to 175 centimeters. That's that one bin. And then the y-axis tells us how many of those individuals are in that range. So each blue vertical bar represents the number of people in a particular height range. For example, the tallest vertical bar tells us there are around 120 people having heights between 165 centimeters and 170 centimeters. So a couple of observations. Most people are between 160 centimeters to 180 centimeters. And this makes sense because the global average height is around 170 centimeters. There are a few people having heights below 140 centimeters or above 200 centimeters. So these are kind of the extreme values. Now, distributions come in all shapes and sizes. Some have a single peak, as in this one. Others have two peaks, and some have no peaks at all. Some have long tails, some are wide, and some are really narrow. And here's some example distributions. So this is called a two-peak or bimodal distribution. Bimodal simply means that there are two modes, and a mode is simply a popular value. So you can see here that this graph has there are two points in this graph that are really intense, and there's a lot of values there. So that's why it's called bimodal. We also have the uniform distribution, which is kind of like an even uniform distribution. There are no obvious peaks. There are no it's just all even and pretty uniform. And then we have the skewed or the tail distribution. So this one, it kind of like tapers off at the end, and there are many forms of this tail distribution. You can have really long tails, short tails. As you can see, there are a bunch of different distributions that you can have. And remember, a distribution is just a group of values. Now, there's a special type of distribution called the Gaussian distribution, and it's arguably one of the most famous distributions. Now, it also has a couple of names, so you might hear it as the Gaussian distribution, the normal distribution, the standard distribution, and I'm pretty sure there are other names. But informally, a Gaussian distribution is any group of values where the values are symmetric about the mean, and most values are around the mean. So we can easily check these conditions by looking at a histogram. So here we have a distribution of IQ values, so intelligence quotient values. And intelligence quotient is a common example of a normally distributed variable. So the distribution is symmetric around the mean. The average IQ is 100, which is right here. And you can see that it's symmetric. So on the left, it looks pretty much similar to the right. And also, most values are around the mean. So a lot of people have IQ around 100, and less people have IQ values at the extremes. Now, the reason Gaussian distributions are famous is because they appear frequently in the real world. And here are just a few real world variables that all have normal distributions: height, IQ, birth weight, SAT scores, and reaction times. Well, that's it for statistics. Um, I'll leave the link for the article in the description box below. Here are some great resources to learn more about statistics and probability. I haven't delved too much into probability because I want to keep the article lean and simple, but you can always dive into probability more if you would like to. And these are some great resources to learn more about those topics. Um, so yeah, that concludes this article. We learned in this article we learned a lot about linear algebra, calculus, and statistics. For linear algebra, we learned vectors are just lists of numbers, matrices are tables, the dot product converts two vectors into a single number, matrix multiplication is just a bunch of dot products, and matrix transposition is just a good old switcheroo of rows and columns. In calculus, we learned that the slope, derivative, and gradient all mean the same thing. They define the rate of change of one variable with respect to another. And to minimize a function, you can use the derivative. A cost function tells us how bad an ML algorithm is doing, and therefore we want to minimize this cost. In statistics, a group of values is called a distribution. Given a distribution, we know how to calculate the mean or the average, the median or the middle, and the standard deviation or the spread. You also know that the famous Gaussian slash normal slash standard distribution, and that appears often in the real world. Well, that's it for this article, and what I would recommend further is you check out those resources to learn more about these topics: linear algebra, calculus, and statistics, and probability. If you want to understand machine learning at a deep level, I would highly recommend going through the maths, taking some time to really understand the maths powering these algorithms. And again, I provided a high level overview in this series, in this article, but there's so much more to learn and explore. So I would highly recommend just diving deep and learning those fundamental concepts. But I hope you gained a lot of value from this article. If you have any questions, please feel free to leave them in the comment section below. And that's it for this video. Hope you enjoyed. Make sure you like and subscribe if you enjoy the content. And I will see you in the next one. Peace.